Hey there everyone, CPO here, and I'm getting ready to convert my standard fly barless head on this Tarot 450 Pro V2 to a DFC head, and I wanted to talk a little bit about that conversion process, try and explain the differences between the DFC swash and the standard fly barless swash. Also, I'll try and remember to talk about the differences in length between the DFC main shaft versus the standard fly barless main shaft, because they are different lengths. The DFC I'm going to put on for this particular part of the build is I'm going to use the Split Lock DFC from Tarot. I really like this this head, so this is what I'm going to put on, and let's go to it. So the big question here is, can this regular swash be used with a DFC head? Let's take a look. Alright, so this is a little bit of a mock-up here, not a final installation, so you'll notice like my Jesus bolt isn't actually installed in here to hold this shaft to the head. But the key here is that, can the DFC head be used with a standard swash? And the answer is yes. Basically, what it boils down to is you're using 2 balls instead of the 4 balls. And the reason is now both the rotation of the head and the pitch of the blades is handled by only these 2 lengths. Alright, so these 2 balls right here are doing the work of all 4 balls on the standard fly barless head. And it's a direct flight control. And that's basically how that works. And as you can see, if I lower the swash, it changes the pitch of the heli just the same as on the standard fly barless head. Alright? So the difference is, like I said, these 2 are combined. These 2 functions, the rotation and the pitch, are combined into one ball on each side. So what happens is a lot of guys will just remove the extra 2 balls off the standard swash and fly it with the standard swash, and that will work. However, the challenge is a lot of people are having problems with all the forces applied on the single ball with the links popping off in flight, and that is why we have the development of the DFC swash. So let me show you the differences between the 2 swashes now. Okay, so here are the 2 swashes side by side, the standard fly barless swash and the DFC swash. As you can see, the 3 balls that mount to the servo arms on the heli are the same. So we're really only focusing with what connects to the head and above. So ruling out that these are the same, let's start looking at the swash plate itself. So let's look at the differences between these 2. Basically, on the standard fly barless, your balls are basically lined out in all 4 quadrants, directly across from one another, and all facing out from the center line. On the DFC swash, your balls are placed in the same quadrants. However, the balls are angled differently. Alright? So you have 2 of them that are basically at a 90-degree angle from the standard swash. Instead of pointing out, they point, up in this case. And then you've got these other balls that have a slight tilt to them, but for the most part are facing out like a standard swash. So what I'm told is that the reason that these balls are placed at a 90-degree angle is to facilitate the reduction of the links popping off in mid-flight. Alright, again, taking a look at the main shafts for the standard fly barless system versus the DFC, and you can see this is the standard. The DFC is a little bit shorter. The DFC head fits closer to the helicopter. Alright, so I've got the fly barless main shaft on the caliper, and it is looking like it's going to be about 118 millimeters. Okay, and let's stick the DFC, and that one is looking to be 108-ish. So looks to be about 10 millimeters shorter. At any rate, you want to use the short one. Don't put your full-length main shaft on there when you convert to DFC. And a quick way to check and see which direction the main shaft goes on the DFC, I forgot about telling you this whenever I put it on, but basically the longer distance from the collar cutout to the end is what's going to go down. And you can compare it and see with the standard fly barless main shaft, these two are going to be identical, because from the point where it connects with the top main bearing all the way down to the main gear, which will be down here, that's all going to be the same length. Where the difference lies in the dimensions is it's shorter up at the top. So you'll have the longer end pointing down from the collar mark, and then the shorter pointing up. So hopefully that helps you. If you get confused, again, like I said, grab your standard fly barless one and get it the two parts that line up. That's the down part. The variable part is what's up. So anyway, hopefully that helps. All right, so now I'm ready to put this head on. I am going to go with this DFC split lock head, and basically it's a pretty simple install. I like the way it's got these markers for zero pitch. So what you can do is you can get this thing set into place. Use your Jesus bolt to get the main shaft locked in. And remember, on this particular setup, you do not need thread locker on this Jesus bolt. And the reason is, let me show you this. And mine's already pressed in there. You've got a lock nut right there. So no need for thread lock. Just get it on there. Get your holes lined up in the main shaft. And tighten it down. Okay, so that's there. Now we've actually got the split lock component that we need to deal with, so I'm going to just flip these over here. What I want to do is just unscrew these, apply some thread lock on there. And this is going to lock the shaft in place even further. Okay. Flip these the other side, rotate around, pull out the second one. Now I have already rebuilt this this head assembly, taking it all apart, greasing the thrust bearings, putting thread lock on, all that stuff. So really this is just the finishing touches of the install. Took off the arms, made sure that all these screws here were all thread locked, and I have good, nice, easy rotation, as you can see. Everything moves nice and smooth. Alright, so now what we want to do is put on our links, and let me get these in the right side here. Okay, so you want it just like all the other heads. If you haven't seen the video on the heads or the head install previously, you might check that out. But you know, this is a leading edge control. The blades will rotate clockwise as seen from the top, and you want basically the control to come from this side. So this side will always be on the right because it's going to pull forward. And then as you rotate it, it'll be on the right again. So keep that in mind. All right. So remember, when you adjust your zero or pitch settings on your head, you need to make sure that your fly barless system is in setup mode. I'm using the Robird G31. I'm plugged in, battery powered. Servos are powered. I'm plugged in through USB to my computer, and I'm in the collective pitch tab 4, and have my stick set at 0 pitch. So basically my servo arms are straight 90s across all 3 servo arms, and then from this position, my level swash, and this is where I'm going to set up my my pitch adjustments. So what I'm going to use as a guide for this is these little alignment marks on the head. So rather than trying to zero off of the head block and then zero the each individual blade grip, I'm just going to use these alignment marks for center, which is what they're there for. And I'm also going to use this 90-degree backward-facing ball on both sides. I'm going to leave these other balls on. There's no harm in leaving them there. They're all thread locked in. So the 90-degree backwards ball is the one that's designed to help prevent link pop-off during hard flight. So that's what I'm going to use. And I'm just going to get it kind of centered on there, like I'm pressing it on, but not clipping it on all the way, and take a look at where I'm at. And my arm is clearly too long here. So basically, I'm just going to turn it in a little bit. And you have to be mindful of the A, making sure it's facing out. Those rules still apply. So check that. Need more. Check that. Still need more. And it's looking pretty darn close. Let me try. Oh. It's actually about as far as I can go right there. Okay, rotate this around. I can take a quick test fit, but I can already tell you I'm going to have to screw this bad boy in to match the other one. Which is pretty much as tight as I can make it. Now this is really tight. As you can see, I have to kind of apply some pressure to get it set onto there. That's why they're designed the way they are, and prevent against that link pop-off, is because there's actual pressure applied from both sides at the same time, kind of pushing against that ball. Checking my A direction here. Let's see how that looks. So from here on out, basically what I'm doing is I'm looking at the length of the arm from the blade grip to the swash, trying to get my pitch adjusted there, while also factoring in the fact that here I need to start lowering my swash, because my arm on the blade grip is already as short as it can physically go. The only way to get more length out of it, out of that space between the blade grip and the swash, is to lower the swash. And so for this part, I end up going through and lowering the swash evenly and putting a swash level back on it so that I can get it lowered down and still have enough room to work with those links. So this is kind of a back and forth thing where you check the pitch marks and figure out if you need more room, go lower the swash a little bit more, check the pitch marks, back and forth, back and forth. I'm not going to bore you with that, but I will skip forward now to the part where I've pretty much got it figured out, the links of each of the links from the servo arms to the swash, and then from the swash up to the blade grips. All right, here's a little tip for you for taking off these DFC links. As you can see, you get in here, and if you've ever tried to take one of these things off, you can't get a tool in there. You can see I've nicked my anodizing off, probably as many of you have, trying to figure out how to get these things off. The easiest way I found to do it, counterintuitive, but take it off from the top. So if you unscrew the arm from the blade grip, you will end up with a free moving arm, and then you can essentially just kind of rotate it off of there. it's an easy way to get it off without doing a lot of damage to your head and to the link. So that's my tip on how to get those things off. So you may notice here as I continue this part of the video, I do have the black DFC split lock head with the orange arm adapters, where before I started with a silver head, and I had an opportunity to do a trade out for this black and orange, and I really like it better. I think it suits the heli better. So you're going to see the second half of this with this different head color. The head is exactly the same. It's still the same DFC split lock head. So all right, so here we are with the completed head assembly. And as I was mentioning before, there's kind of this process of getting your link rods from your swash plate to your blade grip aligned, as well as ensuring that your links between your servo arms and your swash are all even and give enough room for this arm. So I ended up having to reduce the overall total length of these links from the swash to the servo arms quite a bit, actually. I don't know what the current measurement it is, but I had to lower the swash to make room for these arms. So when these are screwed in at their smallest length is basically where I got that swash plate, and then I can adjust up from there to kind of level things out. So it's kind of this back and forth. Lower these swash links here from your servo arms, get everything level. I put the swash leveler back on. Everything's good and level, and then just worked on getting the blade grips centered by adjusting these arms. And I'll show you what it looks like on the top here, these alignment marks. All right, so as you can see, I basically adjusted these arms from the swash plate to the blade grip to get these alignment marks centered on the head block and the blade grips. So as I rotate this main blade, you can see those alignment marks should remain lined up in all directions, and that's going to be indicative of a level swash. And from a visual perspective, I've got these lined up at 0 pitch. Now this should be my starting point for all of my other pitch adjustments, but I don't want to just take this as the de facto that I'm 0 pitch, because quite frankly I want to make sure that, number one, my vision isn't that great to make sure that these are 100% aligned just by looking at them, but also I can't guarantee that these things are exactly centered. Again, it's a printing process on machine parts, so this could be off by a couple of millimeter, and that will change everything. So what I really want to do now is just verify that I've got 0 pitch on the blades. And while I do have a digital pitch gauge, you know, using a digital pitch gauge is a little bit tricky in the fact that you have to have a reference point. So you need something that is exactly in line with the main shaft to get your reference point. You know, previous videos you've seen me use the top of the main block as a reference point, and that works okay. This main block isn't exactly flat, so it's a little bit more difficult. So I'm actually going to go the old-fashioned route to verify 0 pitch, and that'll be with this this standard pitch gauge here. And I'll show you how to use this. And I think, in my opinion, even though I have a digital pitch gauge, I'd rather start with this to get 0 figured out, and then from that, once I know 0, then this is easy. I can use this because my blades will be my reference point at that point. So anyway, I'll show you how this works and how I'll use it to verify that my blades are at 0 pitch. Again, I'm in setup mode in my Flybarless software, so these servos are all at 90 degrees, which has my swash perfectly level, and that's where you want to be when you start this process. All right, so what I use to do 0 pitch, along with my standard mechanical pitch gauge, is this little top head button thing. It's designed for Flybarless pitch leveling, and basically what it does is it screws into the top of your head block, and then you use a standard fly bar from a 450 as your reference point for the gauge. So Basically, I'm just going to screw this in. And when you screw this thing down, you want to make it exactly perpendicular to the blades, and just snug it down. It doesn't have to be super tight. And then you just take your regular fly bar. This is a regular threaded fly bar, and you just zip it through there. And now what you have is a reference point that is exactly perpendicular to the main shaft, and it's used as a guide now for zeroing the pitch on the blades. So I'll show you what that looks like down from a low perspective, and then we'll check the zero on these guys. All right, so here's a view that should give you a good idea of what's going on here. As you can see, I'm in line with my blade. I have the fly bar through the fly bar button there. And basically what I'm going to do is slip this pitch gauge on. And what you want to do off the bat is make sure that you're zeroed out. So make sure that pointer is at exactly 0 before you start. So then I'm just going to slip this on the blade. I like to run it around, halfway in. Make sure it's in there where I want it. And as you can see, the reference between your fly bar and your pitch gauge is what you want to look for. You want to look for that alignment. The other thing is I like to have the blades in a consistent position. So this is directly in line with the tail boom, running parallel to the actual length of the heli, and that's where I like to set that. So that's not too bad actually right there. Again, we started out with the reference point on the blade grips and the head block, and this is a verification with the pitch gauge. Now I could actually get a little bit length here. That would be by lengthening this one. You can't see it through my pitch gauge, but this one link arm here. I'm not sure. I'll have to think about whether or not I actually want to lengthen that. It looks like I might want to a little bit. Let's look at the other side now. Just going to flip it, rotate it around. Again, about halfway on the blade. And that one looks like it's off actually quite a bit more. You can see, and if you want to figure out how much degree that is, right, of pitch, you can use your pitch gauge to find out what the pitch is. Loosening up this set screw, and then now I can adjust this. Okay, so as you can see here, now that I have adjusted the pitch gauge to be level with the bar, this gives me the indication of what my current pitch is. I'll zoom in so you can see. And as you can see here, the marker has it about 1.5 degrees. So that's quite a bit off 0 for my taste. So that is checking against the reference points that are on the blade grip and the head block. But this is a more accurate measurement, and I think I'm going to make a finite adjustment on the arm for the blade grips to bring this up a little bit closer to 0. So I'm going to see what it's going to do to extend that out 1 screw turn, and we'll get this thing, see if we can get a little bit closer. And remember, as I mentioned before, I think it's easier to adjust this by loosening it from the top. And just remember, when you have your final adjustment, you want to apply that thread locker to lock in that screw the last time. But if I remove this, then I can actually raise this up by turning this, and remember, you got to turn it around all the way one time to get it lined up. Put your screw back in. So you can see now, after raising that arm one complete turn, now I'm lined up almost exactly at 0. That's about as close to 0 as I'm going to be able to get, and I think that's just perfect. So again, the reference marks are great to get you started, but you want to verify with an actual pitch gauge. Let's go ahead and adjust the other side, and then we'll take a look at those reference marks and see what they look like once we get done with this operation. So just rechecking the other side, actually didn't move the pitch gauge at all. It's still at the same place it was from the other blade, and as you can see, it looks like it's about as good as I'm going to get it in comparison with that fly bar. So the good news is I just had to make one adjustment on one arm, and that's good. So let me Loctite down that other arm before I forget, and then we'll take a look at the top of the head and see how those alignment marks look now that I've actually zeroed the pitch using the gauge. All right, so here's what the top of the blade grips and the main block look like after adjusting the final adjustments for 0 pitch, and it looks dramatically different, doesn't it? No, it looks exactly the same to me, which is my problem, right? It's not that the marks may not be perfectly aligned, it's how able am I with my human eye to discern the difference between a smidge different alignment. So I use this as a guide. It's pretty accurate. This one may be just a little further off center by my eye than I would have thought it would be. But either way, these are alignment starting points. So if you're setting up your 0 pitch just using these guides alone, you may be dead on. You may be really close. It's up to you how important that is to you. I can tell you what you can do if you don't have a pitch gauge and you want to just line it up with these marks, and then just check it. Fire up the heli. Take a look at your blade tracking. If these are not exactly the same, your blade tracking is going to be off. So just keep that in mind. But at any rate, that's what it's going to look like now on the completed assembly. I can go put a head button back on, which is my indication that I'm done with this part of the build. I can really see now that I have this thing installed how these 90-degree back turn balls actually hold these arms from popping off. There's pressure because of the relationship. I'll bring it up this way. Because of the relationship with how this is kind of angled and set down inside that ball, there's pressure on the ball pointing this direction. I mean, these things, it takes a little bit of force to kind of tweak them back because of the angle of how this is set up. So I don't know how else to describe it, but it really does make sense to me now why those balls are turned backwards and how that is such a huge benefit for this design head. All right, so now that I have the head back together, we have the pitch zeroed out at center stick. Now I can finish the rest of my pitch adjustments with the digital pitch gauge. I have the Tarot digital pitch gauge here. So once again, I have the blades aligned with the length of the heli. I'm still in setup mode on my software, and I'm at mid stick. And basically now what I want to do is adjust 12 degrees positive and 12 degrees negative pitch. So I'm going to set my pitch gauge. Again, I like to go to about the middle. In this case, it's a little bit heavier. I'll go a little bit more on the inside. Get everything kind of set up, centered there. And then I'll just hit the power on the pitch gauge. And that should automatically leave it in the zeroed position. All right, so I want to make sure that my transmitter has full throttle curve range. So because I have throttle hold on while I'm working on this, which I totally recommend you doing at all times, I'm just going to change my hold pitch to a full pitch curve, and yours may already actually be there. Mine wasn't there, but I'm setting it that way now. So basically, in the hold position, I have 0 at low, 25 mid, 50 75, and 100. That gives me the full range of motion while I'm in throttle hold mode, which is where I want to be while I'm playing around with this. Because if I drop this throttle hold off, the flybarless software should keep it from kicking on the motor, but the reality of it is I've actually had the flybarless software freeze on me or close up, and it engages the heli again. So if I didn't have throttle hold on and my throttle was at mid stick, it might have just started firing up the blade. So as a safety precaution, I always leave throttle hold on while I'm doing this. And if I need to make pitch adjustments, pitch curve adjustments, I do it in the throttle hold section. All right. So I'm at mid stick on the transmitter. I'm going to bump it up to full collective pitch, and what I'm looking for is 12. I'm not quite there, so I'm going to make a couple of bumps on the software to hit 12. Maybe one down. A couple of points isn't going to make that big of a difference. Okay, I'm going to go down full negative pitch. Again, I'm looking for 12. Making these adjustments in the software, not in the transmitter. Okay, back to center. Back to full. And again, a fraction of a degree isn't going to make that big of a difference. I just like to get it as close as I can. So there's my 12 degree negative, 12 degree positive, all based off of a 0 degree blade position, which we did with the mechanical pitch gauge. So that is it. That is setting up the flybarless DFC head. This was a conversion from a standard flybarless head. Actually, this guy here that came with my kit, it was a conversion from this to that. Required changing a couple of links between the servo arms and the swash, using the shorter main shaft. Used the head button that was on this original head. The head button comes off, and I put it on the DFC. The DFC head does not come with its own button, so in case you're aware of that. Pretty awesome. I'm ready to go fly this thing, and as you can see, the heli is ready to be flown. So kind of excited. Basically went through a total rebuild on this thing, and she's ready to go. So, at any rate, thanks for watching, and I'll catch you on the next one.